Now, see here in this experiment, that is actually an original experiment of the Geiger and Marsden. Geiger and Marsden calculated the distance of closest approach to the gold nucleus Z is equal to 79 of a 7.7 mega electron volt alpha particles before it comes momentarily to rest and reverses its direction. What is its value? So, we have to calculate actually the value of the distance of closest approach. We know it R naught is equal to 1 upon 4 pi epsilon naught twice of Z E square upon into half mv square, that is kinetic energy. Everything is given to us here. 1 upon 4 pi epsilon is, that is a 9 into 10 raised power 9 into 2 into 79 into E, that is a charge, that is 1.6 into 10 raised to power minus 19 square divided by, here this whole kinetic energy is given to us 7.7 mega electron volt. So, we can write 7.7 into 10 raised to power, that is a mega electron volt, we can convert it into joules. So, we can write 7.7 into 1.6 into 10 raised to power minus 13, that will be coming into meter. When we solve this, we will be getting 3.0 into 10 raised to power minus 14 meter, that can be written 30 Fermi. Now, see here, if you have taken here like a gold nucleus over here, that is a alpha particle over here. This is the distance of closest approach, that is R naught. Now, this R naught has come 30 Fermi, that is actually equal to, approximately equal to sum of the here the radii of these two. So, with the help of this, it can be calculated, or the size of the nucleus can be calculated, but it is not 100% correct or the good approximation, but we can estimate the size of the nucleus with the help of this, because R naught is taken approximately sum of the radii of these two nucleus, because at this distance actually alpha particle do not touch to the nucleus and it gets rebounced. So, this distance can be taken as here the sum of the radii of these two nuclei.